All right, here we go. So we're going to try and sketch a graph of the function x over x squared plus 8x plus 15. As we go through these problems, what I want you to do is first stop, try them yourself. When you get stuck or you cannot move forward, do your best to work it out yourself, and only once you have done that, go ahead and play the video. And once you get to a point where you have moved on from that conundrum, try and continue on yourself, pausing the video and only starting again once you need a little more help. And that will really help solidify your understanding. All right, so the first thing we want to think about is what are the x values that I cannot have? Where is my function going to be undefined? So my function is going to be undefined. My denominator, of course, is 0. And to solve that, I'm just going to use my quadratic formula to solve for x, and I'm going to get that x is going to equal -5 or -3. Both of those will result in my denominator being equivalent to 0. So 1, 2, 3, 4, 5. So my my vertical asymptote totes will be right there. And now I want to think about what will happen to my function as I move closer and closer to infinity or negative infinity. So my horizontal asymptote, I'm considering what is happening as x approaches infinity and negative infinity. And so if I look at this function, this is pretty easy, because think about what happens as my x value gets bigger and bigger. Well, my denominator is going to get even bigger because I'm squaring that x value. So here we're seeing that as x is getting closer and closer to infinity, well, my function x divided by x squared plus 8x plus 15 is getting closer and closer to 0, or to the line y equals 0. So my horizontal asymptote is going to be the x-axis. And you might want to just try some values here. Maybe plug in 10, and then 10 squared is 100. Plug in 100 and then 100 squared, and see how that's getting smaller and smaller. Next up, we want to start actually taking some points that we can put on the graph. Because think about what we know right now. We know it'll happen as we get closer and closer to positive negative infinity. We know that we can't have any values at our vertical asymptote. This is getting closer and closer to 0, so I'll either be getting towards positive infinity or negative infinity there. And so now we just want to find a couple points, and let's be really specific. Let's find the points where we are on the x-axis, because if we find those points, then we'll be able to say, all right, if we know all the points where the function hits the x-axis, then for any other point, we know that if it's positive, it won't be going negative at some point in the future, because we've already found all the roots. So we'll find our critical points here, and the first thing that we're going to find are our roots, and this is quite simple. There's only one root, only one value that makes my numerator 0, and that's when x equals 0. So I can plot that point right there, and at this point I'm ready to make my sign chart and evaluate what's happening. So my sign chart is going to contain my critical values, and the critical values are all those x values that are really critical. Well, I know that at -5 I can't have any value, so that's critical. I know that at -3 I can't have any value, and then I also know at 0. So my critical points are going to be -5, -3, and 0. And as we go through here, you'll want to test out values. So if you plug in -6, you're going to find that you're going to get a negative value. If you plug in -4, you're going to get a positive value. If you plug in, say, -1, you're going to get a negative value. And if you plug in a positive number, of course, you're going to get a positive value. And so I can just take it quadrant by quadrant, or maybe quadrant by quadrant is the wrong term, piece by piece. So to the left of -5, my function is going to be negative, and it can never be positive because that would require it to cross the x-axis. So I know that my function is going to approach 0. It's never actually going to get there, right? That horizontal asymptote. In between -3 and -5, it is always positive. Now this one's a little tricky. We know that it's approaching infinity. It's getting closer and closer to being undefined here. And then it will come down, and then we'll also have to be approaching infinity as I get closer to -3. So it'll look like that. I will then be negative. It will go negative here. And it will approach the asymptote. It will hit the asymptote. It crosses the axis at that asymptote because it changes from positive to negative. It will go positive, and then we'll get closer and closer and closer to 0. So there we have the graph of our function. All right, we're trying to graph the function x squared plus 8 divided by x. And just like we did previously, we want to limit our x values to x values that are truly critical. We don't want to go plotting a ton of points. And so first off, we're going to try and find the x values which we cannot have. And this is pretty simple. Since we're looking at a fraction, the only values that will really not work for us are when x is 0, because that will make our denominator 0. So we're going to have a vertical asymptote at x equals 0. Now we want to think about what's going to happen to our function as x gets really, really big or really, really small in the negative direction. So negative, 9 million or positive 10 million, whatever it may be. What's happening to our function? And so, we could try plugging in bigger and bigger values here. And it might lead us to the answer, but it would be more helpful if we could simplify our fraction here and really get a better idea of what this is. And we can do that by dividing. So if I were to do the division, x squared plus 8 divided by x, I'm simply going to get x. Let me tidy that up a little bit. I'm going to get x. And then after this, x times x is x squared. These will cancel now. And I'm going to be left with a remainder of 8. So my function is going to be x plus 8 divided by x, right? That's how I include my remainder. And so what's going to happen to this as x approaches positive or negative infinity? In other words, what's my horizontal asymptote going to be? So as x approaches positive or negative infinity, what's going to happen to my function? Well, x plus 8 over x, what's that going to get closer and closer to? So what this says is as x approaches infinity or negative infinity, my function is going to approach what? Well, let's say we have this x here, so whatever x is, that's x. And what are we adding to it? Well, we're adding 8 divided by x. As x gets bigger and bigger, this is getting closer and closer to 0. So I'm just left with x, because think about what happens when you plug bigger and bigger numbers in here. 8 divided by a bigger and bigger number gets smaller and smaller. So my horizontal asymptote is going to be the line y equals x. And now we are really, really close. We'd like to know what roots we have. Once we find the roots, then we're going to be in great shape. And that should be pretty simple. That's when the numerator is going to be equivalent to 0. So take a look at your numerator, x squared plus 8, and you'd want to know when this is equal to 0. Well, before you do that, just think about what this is saying. You're taking a number and squaring it and adding 8 to it. Will that ever equal 0? Never. Square of a number will always be positive, and when you add something to that, it will continue to be positive. So there are no roots. So my only critical value that I care about here is where it's undefined, at 0. I plug in a number to the left of that. That is going to give me a negative value, and a number to the right side of that is going to give me a positive value. So now I know how this is going to look. It's always best to start on the closer to the undefined aspect. So I know it's going to be negative. It's getting closer and closer to being undefined, and then it's going to have to get closer and closer to the asymptote as I get further towards the negative infinity. On the right side, once again, it's positive, closer and closer to being undefined, and then closer and closer to that horizontal asymptote. All right, so here we're trying to figure out what is the horizontal asymptote of the function f of x. And of course, the horizontal asymptote is what is happening to my function as I get closer and closer to infinity or negative infinity. So as x approaches infinity, either positive or negative infinity, what is going to happen to my function? So I can think about my function, x minus 7 divided by x plus 1. And so what is going to happen to this function as x is getting bigger and bigger and bigger? And what I would encourage you to do right now is pause, try some values out. See what happens when you plug in 10. What happens when you plug in 100? What happens when you plug in 1,000? What are you noticing is happening to your function? And when you're finished, go ahead and then think about why that is, and then press play again. All right, so hopefully that was good, and you saw that what's happening is as this gets closer and closer, as x gets closer and closer to infinity, our function, I shouldn't say equals, but our function approaches the value 1. And the reason that is because when x is getting very, very large, if x is close to infinity, this negative 7 means very little, as does this plus 1. And so what we really have is x divided by x, which is 1. The easy way to see this is to simplify our function. If you divide x minus 7 by x plus 1, you'll get that it goes in one time. And you'll end up with a remainder of 8. I should actually show all my work there. Okay, I'll end up with a remainder of 8. So I have 1 plus 8 over x plus 1. So as x approaches infinity, my equation is going to get closer and closer to 1, and I can see why that is. Let me just write it analogously. As x approaches infinity, my function, which is just 1 plus 8 over x plus 1, what is that approaching? Well, this is easy to see now. We have some number 1, and then we're adding 8 divided by x plus 1. Well, what happens is 8 gets bigger and bigger and bigger. Try it out. This is eventually going to get closer and closer to 0 because the denominator is getting bigger and bigger and bigger, and so my horizontal asymptote is going to be 1. What does that look like on my graph? That means that as x is getting closer and closer to infinity or negative infinity, my function is getting closer and closer to this line, y equals 1. So my horizontal asymptote is going to be y equals 1, which is that line right there.